revolutionizing the way that you learn. Need math help? Well, come and have your turn. Stress-free learning.
Start a fresh new page every morning and make it a great one. Boom, what's popping? What's happening, guys? So today we'll be doing analytical geometry. As you can see, I've already written it down to quicken the process because this stuff is revision. It really isn't new stuff. You already know this stuff. We're just revising on a couple concepts so that we are on the same page, just in case you forgot, right? So the first thing is you should remember your distance formula. As you can see, it's just equal to AB is equal to the square roots of, in brackets, x2 minus x1 squared, right? It's take note that it's x and then there's y by itself over there. And don't forget your squared, and there's a plus in between, right? So that's your formula. You should know that, and you can commit that to memory, or you can look at your data sheet if they provide you with one, right? And then the next formula you should know is the gradient formula. The gradient formula is basically a formula you've been using for a while, so you should know that formula. It's y2 minus y1 divided by x2 minus x1, right? You can also write it as y1 minus y2 over x1 minus x2, right? So there's another formula you should remember, which you might have to use more often than you think, is the midpoint formula. The midpoint formula is just in a coordinates system, right? So midpoint formula says that the extreme value plus the other value that's at the beginning, you add them together, then you divide by 2, which makes sense because it's a midpoint. So it'll be x1 plus x2 divided by 2. And then on the y coordinates, it'll be y1 plus y2 divided by 2. And those are your two coordinates for your midpoint, right? Another formula that you should not forget is tan theta is equal to m. Tan theta is equal to m is what allows you to get angles and to look for angles in the shape of in analytical geometry, right? So, and another thing, let's discuss the gradients of two straight lines is the same. What am I saying? I'm saying that these two lines have the same gradients. The line AB and the line below it, that's parallel to it, have the same gradients, right? Why? Because they're going in the same direction, right? The only difference is their height or elevations in a different place. They cross the y-axis in a different place, right? But one thing you should take note of that you use in almost every question that you get on analytical geometry is that the gradients of a line that's perpendicular to another are inversely proportional. They are reciprocal and they are negative. What do I mean by that? This is what I mean by that. M of AB, right? That line there, the gradient is equal to negative 1 over M of DC. Right? So what does that mean? It means that if I have a gradient of 2, let's say for example for line AB, the gradient for line CD would be negative half. Why? Because I'm going to say negative 1 over the gradient of AB, which becomes negative half. Right? But to just check, just in case you're not too sure about what you did, you can check this by this formula here. You can say MAB times DMDC is equal to negative 1. So if you multiply your two gradients together, it should give you the answer negative 1. So my example again, using 2 times negative half. 2 times negative half will definitely give me negative 1. Why? Because 2 times negative 1 over 2, the 2's will cancel out and you just left with negative 1. Which proves that those two lines are perpendicular to each other. If you get an equation, right, and you calculate your equation, and then you find the opposite, the gradient of the perpendicular line, but when you test it, it does not equal negative 1. That means either those two lines are not perpendicular to each other, or you did some calculation wrong, right? You might have forgotten your negative sign, right? So that's formula you can use it to prove that A and B are perpendicular to each other. Right? So let's do a question so that we're on the same page and you understand what I'm talking about. So get your book, exam pad, whatever it is, and let's start doing example 1. Example 1, what does example 1 say? It says calculate the length of BC. So it wants us to calculate the length of BC, right? 3 marks if you ask me. Determine the angle A. The angle A is that angle at the top there. We want to calculate what that angle is, right? Seems complicated because I don't see any angles in that shape, right? But it's pretty straightforward. we start doing it, right? So now the last one, C, it says if line A is extended to make D, right? Let's say the line A is extended to make D, wherever it could be in that direction, could be in this direction, could be in that direction. The mid. Eat well before you write your exams. Not only is it good for your health, it's also good because you won't have to worry about a growling stomach during your exam. Imagine your quiet exam room and then your stomach is out there making noises. So yeah, eat before you write your papers. The point between A and D is M. So the midpoint between the line A and the point that we just extended to D is M, -1 and 5. So, but looking at this coordinate, we can tell that the line will be coming in that direction, right? So now it says, the question says, find the coordinates of D. So we want to find the coordinates of D. Whatever D is, that's what we need to find the coordinates of, right? So let's get started. Let's start with A, the easy one. The easy one, I don't think I need to go through it too thoroughly, right? Because you already know how to do this. So I'll say BC is equal to, I will not write the formula. The formula is right there. So I'll write it like this. So what is in the formula? It says x2 minus x1. What is my x2 between my points B and C? My x is 4. I'll say 4 minus 3, which becomes 4 plus 3, right? Squared plus. Okay, again, you have to start in the same place, right? -1 minus -2, which will give me -2, which will give me +2, right? Squared. So the whole thing is square rooted. And the answer that I get is equal to, if I say 4 plus 4 squared, okay, just put this in your calculator. Don't bother yourself, right? Put it in your calculator. When you put it in your calculator, the answer that you should get is 5 root 2. 5 root 2 units, right? Because you have to give it some dimension, right? Because it's a distance, right? So that's A. That's basically your free 2-3 marks right there. Just take them, collect them, bag them, and move on, right? So it says determine A. What is A? A is the angle over there at the top. So how do I determine that? How do I get angles in a place where there are no angles at all, right? If you remember, if you were listening to what I was saying a few seconds ago, you have to use that formula tan theta is equal to M, because that's the only formula that relates like gradient and all that stuff to an angle, right? So what does it mean? Because I'm looking for an angle. So I catch. I'm looking for an angle, right? So I need to find the gradient of AB and AC. You probably asking, why am I looking for those angles specifically? Because if I can get the angle either this one or that one, or this one or that one, then I can find what that angle A is by the sum of a triangle, which is equal to 180, right? So let's get started. So the first gradient I'll calculate is the gradient of AC. So MAC is equal to, right? The formula for gradient is right there. So I won't write it again. So, but you should write it again, right? So angle of MAC, right? A and C. So I'll start with this point. So it'll be 4 minus 1. So it becomes 4 plus 1 divided by 2 minus 4. 2 minus 4, which is equal to, what is that equal to? It gives me 5 over -2. So it becomes -5 over 2. That is my gradient for AC, right? So now let me look for gradient for, AB, right? Again, formula is right here. What do? I say, let me start with A, right? Let me say 4 minus -2 becomes 4 plus 2 divided by 2 minus 3 becomes 2 plus 3, right? So 2 plus 3 at the bottom. So what is my answer? My answer is 4 plus 2, which is 6 over 5, right? So these are my two gradients, right? Is it gradients or gradii? Whatever. Anyways, so what do I do now? Now I have the gradients, right? Now what formula do I take? I use that formula that says tan theta. So tan theta is equal to M, right? So what formula? What do I want to calculate first? Let me calculate the angle of AC, the line AC, right? So I'll say tan theta AC is equal to MAC, right? The M of AC is equal to what? Negative 5 over 2, right? I have negative 5 over 2. So now I can just find what the theta AC is equal to by tan inverse on both sides. So it will be tan inverse of negative 5 over 2 in your calculator. And the answer that you should get is 68.20. That's the answer that you should get in your calculator. 68.20. Right? So now let me calculate the loss, the other angle. Tan theta AB is equal to MAB, right? So let me replace with the values, right? What I know MAB, right? So it'll be tan theta AB is equal to 6 over 5. That is the gradient of the line AB, right? We calculated that. We know that. So how do we find theta AB? You look for the tan inverse on both sides. So it'll be tan inverse of 6 over 5, which should give you 50.19, right? 50.19 degrees. So you have your two values now. You say, okay, I have my values. Now what? Now what? Okay, let's look at it like this. Let's look on the graph. Let's look for the first. Let's start with line AC. Line AC is that line there, right? So the angle 68.20. What do you think? Which angle do you think it is? Right? Which angle do you think is 68.20 there? It can't be that one there. Why? Because that angle is definitely above 90. Why? Because that angle is going backwards. Because the x value over here is greater than the one over there. So the line is slanting in a decreasing fashion, right? So it's decreasing. So it has to be that way. So that means that the smaller angle has to be 68.20. And on the other line, the line AB, if you look at it again, that line is increasing. So the line is slanted like this. So if it's slanted like this, it means that the smaller angle is the one on the inside. So this is the angle on the inside right there. So we have 50.19 on the inside. So what angles do we have? We have the angle on the inside. We have this angle here. We have that angle there. So now what can we do? We can calculate what the value of A using the sum of a triangle. What do I mean by that? I mean that angle A is equal to 180 minus 68.20 minus 50.19, which is equal to, what is that equal to? Put in your calculator. The value that you should get is 61.70 degrees. Right? Those are the values that you should be getting for the angle A. So now let's look at C. What does C say? C is if a line is extended to make point D, midpoint between A and D is negative 1,5. So let's extend A, right? We extended A, right? Let's assume that point there is D, and let's assume that point there is M, because that's the midpoint, right? So now once we have that, what do we do? Okay, let me erase the ones I've done. Let's make room. Roomba. Okay, so C, right? C. So what formula am I going to use? I'm going to have to use the midpoint formula. Why? Because I do not have any value on D. D, I do not have any coordinates. So, but I do have the coordinates of A, which is the point where it starts from, and I do have the midpoint. So, let's write the midpoint formula. It's right there, so I won't rewrite it again, right? So, how do I get this? So, let me write x1 plus x2 divided by 2, right? That is equal to the x coordinates of the midpoint. Do I know the midpoint? Yes, I do know the midpoint. So the x coordinate of the midpoint is equal to negative 1. Right? You see where I got this? Right? x1 plus x2, those are the coordinates of the different points. Right? But the answer of this is the midpoint. And I have the x coordinate of the midpoint. Right? So this is what I have. So I can solve for this. Why? Because I can substitute because I have one x value. That's the x value at the beginning at A. So this will be 2 plus x2 divided by 2 is equal to negative 1. And if I multiply by 2, it becomes negative 2 on that side. Minus 2, it becomes negative 4. So x is equal to, x2 is equal to negative 4. Right? So I have an x coordinate now for D. And then let me look for the y coordinate. So it will be y1 plus y2 divided by 2. What is it equal to? It's equal to the y coordinates of the midpoint, which is equal to, which I have, which is 5. So if I substitute the values again, and I say y1 is 4 plus y2 divided by 2 is equal to 5, right? So y2 is now equal to, what is y2 equal to? If I multiply by 2 on both sides, it becomes 10 minus 4, it becomes 6. So y2 is equal to 6. So the coordinates of D, right, are negative 4 and 6. And this is your final answer. And you have answered the question and you get your full marks, right? This question was easy, right? Right? So anyways, yeah, go do it. Go do it yourself. Stop, don't look at the answers. Go try to do the exact same question and see what you get, right? See if you got the concepts. Because this stuff is easy. This is revision. This stuff here will come in your exam and it will be free marks. So collect them, bag them, and go. Okay, boom. Go check out the next video.